Now, in this video, we continue with our discussion of exponents. We have already seen the definition of an exponent. We also discussed the different laws of exponents and how they can be applied in simplifying expressions. So now in this specific lesson, we will be looking at the other bit of exponent, which is commonly known as, fractional exponents, or fractional indices, or fractional powers. We will also look at how the concept of exponents can be used in solving equation, in solving for some unknown. So right away, let me share with you a screen that will guide us on how we have to get going on this concept of what? Of fractional exponents. So there we go. We start with the definition that if a number or a letter R is raised to exponent n and it's equal to a, then R can be written as the nth root of a. That is now solving for R. When we solve for R, we will get the nth root of a for as long as n is greater or equal to 2. In other words, a will now be equals to 1 out of, rather R will now be equal to a with exponent 1 out of n, which is what we call the nth root of a. Should it happen that the exponent of a is negative, then well, we can isolate the what? The 1 out of n outside the what? The bracket. Then we have a with exponent -1 inside the bracket. That will give us the nth root of a raised to power -1, or 1 out of a. That also works when we are dealing with a with exponent m divided by n, in which case we can factor m, we bring m inside the bracket, 1 out of n stays outside, and we still have the nth root of a raised to power m. In this case, for the cases above here, a must be greater than 0, R must be greater than 0, m and n are integers. N cannot be equal to 0, because that way it will not be defined. So there we go. Here are some practice questions that we can get going with. The first question is that we write in exponential what? We write each of the expression in exponential form. Well, the square root of v raised to power 3. How do we simplify that? The square root of v raised to power 3. Well, let's get it going right here. So this is question 1. The question is, we have the exponent outside is 3. What we have inside is a bracket. And inside the bracket, we have what? We have the square root of v. Like that. So how do we then simplify this? Well, we can write this as, starting with what is inside the bracket first. This can be written as 3 is outside. Now what we have inside the bracket is v, okay, raised to power, v raised to power half. That's the meaning of square root. V raised to power 1 divided by 2. Divided by 2. Yes, that is the simplification of what is what? It's what is inside the bracket. Now the thing we want to deal with, okay? The thing we want to deal with is, how do we then handle this? it's better to bring the 3 inside and to take the half outside. So that would mean we still have the what? The exponent. Okay. We want to bring half outside. So that means the exponent outside is going to be 1 divided by 2. Then inside, we have a bracket first. Then inside the bracket, we now have v cubed. V what? V cubed. Yes, what we did was just to exchange the positions. Instead of multiplying 3 by 1, then later, bringing it inside. No, that's not necessary. We just bring 3 in and we put half outside. So see what that gives us? That will give us the square root of v cubed, basically that. But if we are to write it in exponential form, unfortunately, then we do not need to exchange this. We just need to multiply this. To write it in exponential form, this step would not have been necessary. We would just multiply 3 with 1 and it will be 3 over 2. So we'll be having v with exponent 3 over 2. 3 divided by 2. Yes, that is the answer, just that. Then for the next question, we have to do what? We have to find this in exponential form. This is the cube root of p squared. All right. So that is the cube root of p squared. The cube root of p squared. I think I need to put this right up here. A cube root of p squared. So where are we? The cube root is right here. The cube root of p squared. Here we have p, but it has got to be squared. The cube root of p squared is what we are dealing with. In exponential, writing the expression in exponential form. So in exponential form, well, this cube root means p squared is raised to power third, okay? It means p squared is raised to power third. So let's have p squared right here. Then we'll be having this expression, and that is going to be outside, like this. Then we have got to have something inside the bracket. Inside the bracket, we'll be having what? P squared. So to simplify this, we'll now be having P. Notice that this 2 will multiply the 1 because it's like this 2 stands out of 1. So 2 will multiply 1 so that we have 2 divided by 3. So instead of having just P squared, we will now be having P raised to the exponent of 2 divided by 3. Yes, that is what we would have in what? In exponential form. Then the third question is asking us to do what? The square root of 6r. The square root of 6r. Well, the square root of 6r can be written as 6r, just have a bracket there. Here we'll be having 6r inside the bracket. Then outside the bracket, we'll be having what? We'll be having this square root thing, which is the same as 1 divided by 2. Yes, then that would be the solution. Now the fourth question is asking us to do what? To write the, let's see, the cube root. Oh, the cube root of x is squared. See, the cube root of x is squared. What's this supposed to mean? And how do you simplify that? Let's write it down. So here we have the bracket. And well, let's start with this. Okay, squared. What is squared? What is squared is the cube root of x. So we'll have the cube root of x like that. So what is this supposed to mean? How do you write it in exponential form? Well, let's first simplify what is inside the bracket. You know, BODMAS allows us to simplify what is inside the bracket first before we get out of the bracket. What is inside the bracket is the what? Is the cube root of x. That is, we can write this as x raised to power what? 1 out of 3. No, not like this. X raised to power 1 out of 3. Okay, 1 divided by 3, like that. And so in the last step, we now multiply 2 by 1, okay, so that we get 2. Then we write the what? The other quantity. So in other words, what we are going to be having finally here is going to be 2 times 1, which is 2 here. And that becomes the what? The final answer. Now you will go ahead and try the what? The remaining questions. Question 5, which is the what? The cube root of 5. Question 6, which is 1 divided by the cube root of 7. Question 7, which is what? Which is, well, the 5th root of the square root of 3. Then question 8, which is the 7th root of the 5th root of 2. So please go ahead and work on that. The next bit that I would like us to look at is to discuss a few numbers, writing this in radical form, okay? Writing this in radical form, meaning writing it with the what? With the square root sign. So to write this with the square root sign, well, the first thing we want to start with is, you know, remember the definition that we had seen earlier on here. These are the definitions. If a is written as 1 out of n, we can write it as the nth root of a. We can also write the nth root of a as that. So we can start from left, go right, or we can start from right, go left. That's what we are dealing with in this case, okay? So for question 9, the first thing we have to deal with is what? Well, just reduce this a little bit. I hope can still be seen like that. All right, so there we go. That's question 9 that we want to deal with. 5, we have 5. 5 is raised to the exponent. 5 has got, is raised to the power of -1 divided by 2. -1 divided by 2. Okay, -1 divided by 2. So how do we then simplify this in a radical way? Well, let's factor the 2. Let's write it as one quantity outside the bracket and the other one inside the bracket. So the one we are going to write outside the bracket is 1 divided by 2. Then inside the bracket, we are going to write what? We are going to write 5 with exponent of -1. 5 with exponent of what? Of -1, like that, okay? Now notice that this can also be written as 5. Rather, this can also be written as 1/5, not just 5. This can also be written as 1/5, and so just one more step there. Outside here, we already have 1/5. Rather 1/2. Then inside, we have a bracket, and our bracket has got in it 1/5, okay? Which is the same as 5 raised to power -1, like that. So what do we then get from here? Well, we can then simplify this to what? We can then simplify this to, we can then simplify this to the square root of 1/5. Well, let's have that inside the bracket, the square root of 1/5, like that. And that is the answer. The next question is question 10. Question 10 is this: 6 raised to power 1/3. Question 10 is 6 raised to power 1/3. 6 raised to power 1/3. So what's this going to be? Well, this is going to be the cube root of 6. The cube root of 6 is written this way: cube root of 6, and that's the final answer. Then the next question is question 11. Now in question 11, what are we supposed to do? Let's check. Well, in question 11, we have 10 raised to power -7 out of 5. 10 raised to power -7/5. Okay. 10 raised to power -7 divided by 5. Well, how do you simplify this? In this case, we are going to factor. All right, let's first write this. We'll be having a bracket inside here and out here. We are going to be having 1/5. We want to have 1/5 outside. Okay, then the denominator is what we keep out, this one here. Then what we keep inside here will be 10 raised to power 10 raised to power -7. -7, yes. Well, what will we have from there then? Well, from here, from this, just copy this and put it there. From here, we would like this to be written as 1 divided by, okay, we'd like it to be written as 1 divided by 10 exponent of 7. Exponent of 7, okay? Notice that this 1 divided by has assisted us to remove the what? The negative. So now we have 10/7 and this. And so the final answer will be, okay? The final answer will be the nth root of this. The n in this case is the 5. So we call this the 5th root. This will be the 5th root of 1 divided by 10 raised to power 7. So how do we write this? Well, we write it this way. Okay, the 5th root, the 5 will appear there. That means the 5th root. Then now this one here stays inside the what? Stays inside the square root sign. Let's put a bracket there to make the work look a lot more decent. And that's the final answer. Okay. So the last question that I'm going to be doing is question 12. You will do the remaining question, which is question 13 to question 16. So question 12 is what? Is 10 raised to power 5/3. 10 raised to power 5/3 is our question. So how do we simplify this? Well, let's first write the question. 10 raised to power 5/3. How do you simplify this? Well, we can write this with the help of the exponent system. We want to keep this 1/3 out. So keeping the 1/3 out, we can then have, well, 1/3 out, then everything else will be inside the bracket. Inside the bracket here, we would like to have 10 raised to power what? 10 raised to power 5, like this. Okay, so now from here, well, since we have this, this is now the cube root of 10 raised to power 5, which is written as this. So we write this as the cube root of what? Of 10 raised to power of 5. Yes, so this is how we do it. This is how we handle the questions. If you are required to write from exponential form to a radical form, okay? This is how you write it. If you are required to write it, okay? If you are required to write the questions in, well, from radical form to exponential form, you write it as we did it here. So these 4 questions are good enough for you. You can continue from there. Now, the next thing I would like us to look at is how we can use the concept of exponents to what? To solve, sometimes to simplify. The question that we are dealing with is this question here, okay? So this is the question, 5 times 3, exponent x minus this, exponent that. Oh, how do you simplify this? Well, let's first simplify. Let's just get this right away. Let's write this question separate as a question that we want to solve. Okay, we want to solve this. We want to provide solution. So this is what we have. We are supposed to factorize this. How do you factorize that? How do you factorize it? Well, the easiest way to deal with this is to write it as shown here. So we are going to keep, just put this, we start with the division sign. We are going to first write the 5 there. This 5 is being used to multiply 3 with exponent x, 3 with exponent x, okay, minus. We have this 9 here. We can write this 9 as 3 exponent 2, okay, 3 exponent 2. Then we use it to multiply what? We use it to multiply 3 exponent x, 3 exponent x, which is this one here, okay? Then we again have to multiply this with the 3 exponent what? Negative 2. 3 exponent negative 2, which is this one here. So we have now separated this. Then the denominator has got what? The denominator has got 3 exponent x, 3 exponent x, which is this, minus 3 exponent x, okay, 3 exponent x right away, which is this one here, then times, okay, times 3 exponent negative 1. Yes, now we have split things. So the thing here is what is common. That is what we want to deal with. What is common? Now you notice that in the numerator, this one is common because it's appearing here. It's also appearing here. So we can factor one of the two out. Okay, so when we factor one of the two out, we will be having 3 with exponent x outside the bracket. 3 with exponent x outside the bracket, like that. Then we'll be having a bracket. So inside the bracket, we will now be having this 5 minus this. Notice that this one will simplify to 1. Why will it simplify to 1? Because 3 exponent 2 times 3 exponent minus 2 will be 3 exponent 2 minus 2. So 2 minus 2 is 0. So 3 exponent 0 is 1. Now the denominator here is going to be what? Well, let me first, yeah, so the denominator here, we will have 3 with the exponent x outside the bracket. Then we will create a bracket. The bracket is going to be represent 1 for this. Okay, we'll be having 1 minus what? Minus 3 exponent minus 1. 3 exponent minus 1. Like that. So what will this lead us to? Well, this is going to cancel out, and we are going to be left with, the 5 minus 1, which is 4. Okay. So this will give us right here. This will cancel out, and up we are left with the 4. Down here we are left with the 3, rather 1 minus 3 exponent minus 1. What's that? That's the same as 1 minus a third. So what's 1 minus a third? What's 1 minus a third, Yel? Just use the calculator for that. 1 minus a third. This is going to be 1 minus a third. A third is the same as 1 over 3. Yeah. So 1 minus a third will give us the value of 2 over 3. So what do we have here? We have 2 divided by 3. You see? So very much like we have 12 divided by 3, you know? This one will give us the value of, we can write this as 4 divided by, so that is easy for you to see, divided by this. Okay, not the whole of that. It's just this section here. Yeah, 4 divided by this. That's what we have. So we can, well, let's start this on a new line like this. So what will this simplify to? This will simplify to 4 times, simplify to 4 times 3 over 2. 4 times 3 divided by 2, which simplifies to what? To 6, because this is 12 divided by 2. Now that's the solution to question 1, which is about factorizing. That's how else we can apply this knowledge. The second question is asking us to do what? The second question is asking us to also simplify. Well, that is 5.1. What do we have to simplify here? Let me first get the question. This is what we have to simplify. So let's put it here on a new page. We have to simplify this. Well, how do we then simplify this? Now, notice that the numerator is where we have a big simplification. This one only can be written as 3 exponent x, 3 exponent. We can put this 2 outside, then inside here we'll be having a bracket, and inside the bracket we can have 3 exponent x. Yes, like that, because x times 2, you know, is still the same thing. Then down here we'll be having 3 with the exponent what? 3 with the exponent x. Right away, okay, that's 1. The numerator will still be having what? Minus 1. Like that. Now in the next step, what we want to do is, notice that this one is the difference of 2 squares. And because it's the difference of 2 squares, we can write it this way. Okay, we can write it as 3 exponent x minus 1 and plus 1. So let me put a bracket there, 2 of them, like that. So the first one will fit in there, then the second one will fit in here. So this is going to be minus. That's what we mean by difference of two squares. The denominator stays the same. So now what you notice is that the denominator is the same as one of the numerators. And so this one will cancel. After cancelling, the next thing we are going to be left with is what? Is 3 exponent x minus 1. That's the final answer of this, if it's to be simplified. Now, the next thing we want to look at is what? The next thing we want to look at is to solve this equals to 26. All right, they said hence solve. Okay, hence solve. What this last bit mean is that after simplifying, okay, after simplifying this, no. Yeah, okay. Hence solve means after then simplifying, we make it equals to 26, then we find the value of x. So this is going to be a very interesting bit of calculation. So we say this one here, which we have now got, we make it equal to what? Equal to 26, right here. So this is what we have. We now make it equal to 26. So how do we then handle this? Well, we just transfer this to this one here to the right hand side, and that would give us what? That would give us 3 exponent x, 3 with exponent x equal to what? To 27, like that. Equals to 27. What do you know about 27? Well, there is one good news here. The thing we know about 27, is that 27 can be written as 3 exponent what? Exponent 3. You see, 3 exponent 3. What can we conclude from here? Well, since the bases are the same, these are the same, the exponent must also be the same, at least if we have equal sign between them. That's how we find the value of x. And that's how we can use the concept of what? Of exponents to solve. The next question to solve is right here. So to solve this one, well, just get it right here. And we put it on a new page where we can do the solving. All right, so we are supposed to solve for x, to find the value of x. How do we solve for x in this? Now, to solve for x from this, well, let's see. We have to solve for x. We have to find the value of x in this. Okay, we have to find the value of x from this. Now, notice that this is very interesting. This question is very interesting. Let's first write this 2. This 2 is multiplying the other 2. Well, let's put it inside the bracket and just try to simplify this. So inside the bracket, what do we have? We have 1 over 2. Let's write 1 over 2 as 2 with exponent what? The exponent minus 1. Yes, let's write it as 2 with exponent minus 1. Then what else do we have outside? We have minus x. Then on the right hand side, we have 5 exponent minus 2 times 5 exponent 2. This is the same as 5 exponent what? 5 exponent minus 2 plus 2. That's what we have. You see? So now the thing we have on the left hand side is what? Is 2, which is this one here with exponent 1, obviously. Then this one here, we can write it as 2 with exponent positive x, because -1 times negative x is going to be positive x, like that. Then what we have on the right-hand side is going to be 5 exponent 0. That is -2 plus 2 simplifies to 0, which gives us 5 exponent 0. And 5 exponent 0 is 1. See that? So in the next step, we then transfer this to that side, meaning on the left-hand side, we are going to be having 2 with exponent what? 2 with exponent x. Like that. Then on the right-hand side, we are going to be having what? We are going to be having 1 divided by 2. That's what we are going to be having on the right-hand side. Now notice that we can still simplify this further. How do we do that? Well, to simplify this, we would like to write, instead of writing 1/2, we would like to write this s2 with exponent what? With exponent -1. Yes, s2 with exponent -1. Now after this, the other thing we want to deal with is, since the bases are the same, the exponent must be what? The exponent must be the same. So we say x equals to what? -1. So yes, this is how, on top of knowing how to simplify or applying the rules of exponents in simplifying, we can also use the law or the rules of exponents in finding the value of some unknown letter in a process known as solving. Yes, this is where our discussion stops. Our next lesson will now be on sizes.